Okay, now we're going to start rewriting and substituting. Rewriting so it's not in fractional form. This is not the v form. Now it's got two terms on bottom instead of two on top. That's the upside down v, which is a little bit tricky. We know that sine squared x plus cosine squared x equals 1. Pythagorean theorem identity. And we also know that cosine squared x equals 1 minus sine squared x, just rearranging it. Then we know that this is a difference of squares, and it factors into 1 plus sine x and 1 minus sine x. So we're going to use this idea to simplify our problem. Okay, let's go back and do 1 over 1 plus sine x. That's where we're starting. As long as I multiply top and bottom by the same thing, I'm not changing the problem. If I multiply top and bottom by 1 minus sine x, what's going to happen to my denominator? Now I've got the 1 plus sine x, 1 minus sine x, which I know simplifies to 1 minus sine squared x, which simplifies even further to cosine squared x. So on the bottom, I'm going to have cosine squared x. On the top, 1 minus sine x. Now I've turned it into the v shape, and I can split it into two fractions. Okay, we split the v. We're going to get 1 over cosine squared x minus sine x over cosine squared x. That's going to leave us with secant squared x minus. Now I want you to take this and think down here. If I have sine x and I put that over cosine x and cosine x, that's the exact same thing. This I can turn into a tangent. This I can turn into a secant. And I'm going to do just that. Make this tangent x, secant x. Okay, try this one. It's going to work out very similarly to the first one. I'm going to replace cosine squared y with 1 minus sine squared y over 1 minus sine y. The top factors two perfect squares, 1 minus sine y, 1 plus sine y over 1 minus sine y. Now that I have it factored, these two can cancel, and I'm only going to be left with 1 plus sine y. Some of you are going to want to cancel this out right off the bat. You cannot cancel this until you have factored it and you cancel entire factors. Okay, let's try some substitution. We are going to be putting 2 tan theta in for x right there. Square root 4 plus 2 tan theta quantity squared. The only thing this part is telling me is that I'm in quadrant 1, so everything's positive. So we keep going. I've got to bring that square into both of these, since this is multiplied. Square root of 4 plus 4 tangent squared theta. They have a 4 in common. I'm going to factor that out. 4 parentheses, 1 plus tangent squared theta. 1 plus tangent squared theta is an identity. So this is 4 times 1 plus tangent squared is secant squared. That's a times secant squared theta. Now, since I only have multiplication underneath my radical, I can break it apart. Radical 4 radical secant squared theta. Simplify that. Now I have 2 secant theta. Okay, try this one on your own. You're going to put 5 sine theta in for x right there. Radical 25 minus, that's supposed to be a 5 sine theta, so I fix that. 5 sine theta, quantity squared. Bring the square in. 25 minus 25 sine squared theta. Factor out the 25. Going to have 1 minus sine squared theta, which is square root 25. That is the same as cosine squared theta. And then I can break this apart into square root 25, square root cosine squared theta, which makes it 5 cosine theta.